It eventually got fixed, so hopefully it will stay that way till the end of the event because my talk is there, so I want people to hear. Okay, so I'm very selfish about that. But before my talk begins, I would like to introduce Mr. Uh, Arumugam Murukia. Did I get that right? I'm very bad in pronouncing names, so sorry about that if I made some mistakes. So, of course, he has a huge experience with quantum as well as AI, and he's going to be our third keynote speaker. The topic is Quantum AI, the influence of artificial intelligence, AI, and quantum computing, QC. So I remember we did a quantum hackathon on AI sometime back with CQE. I'm not sure if you were aware of that, but anyways, that was very interesting, but we were just scratching the surface. But here we are. Nice to hear from you. Please, Mr. Amarnath.
Thank you. Thank you, Ron. I think you pronounced my name very well.
I tried. I tried.
Thank you, Mr. Kolasani, for this opportunity. I think quantum computing and artificial intelligence, the confluence is going to challenge the whole world. We have been worried about artificial intelligence and how it's going to spread and what is going to happen and what's the impact. We have been worried a lot, but now the confluence, which is going to be a great advantage at the same time, it is going to make many things redundant. So let me start with a note. I have these points to discuss: the confluence, the collaboration, and the key areas of impact and the landscape, the collision of two worlds, and the bottom line. This is the content that I'm going to speak. And let's come into artificial intelligence and quantum computing. See, AI is always known for reasoning and pattern recognition. It does pattern recognition so beautifully. Whereas it doesn't have the power of the data processing and capturing complicated mathematical loop. See, when I did a PhD in AI in '89, my paper was complete mathematics. I have to wait for 19 years to process my quiz to prove the world my work is right. Why? Because the computing power in the world was very low. Now it is moved from a very low computing power to super very large computing power. So what we try to think it's impossible, we are able to work so conveniently and comfortably. The good news is that drug discovery, quantum and AI confluence is going to create an enormous impact about drug discovery and finance, cyber security, logistics and supply chain, and space sciences. These are areas which we are also trying to work. Back in India, we are commencing a quantum computing center in Mumbai at a cost of $250 million. We are signed up with IonQ, which is a trapped ion quantum computing from United States, and we are setting up one of the largest center in India, mainly focusing on these areas. So I am the chief of project. I've been working with them, and I'm going to construct this whole exercise. So coming to quantum and AI, we accelerate superposition and entanglement. These two are buzzwords in quantum computing. Superposition, when you go back to quantum computing, I think a physics talked about artificial intelligence. I thought he should talk about quantum mechanics, which is what started in 1900. Max Planck has opened the idea of quantum computing. He made a big shift from all the people who are thinking Newtonian principle of energy is a particle to wave, and that started the concept of thinking quantum as an huge atomic power which we have to use about critical resources. So that idea started exponentially growing over a time. Today, this massive solution space at once, which is more critical, is now met with exponential speeds with quantum. And whereas AI, which helps the quantum, see, quantum is error prone because you can't expect to remain an atomic power and carrying capacity is always resilient. It cannot resilient for a long time. So AI did the mechanics of setting this speed in the right proposition so that it carries this packet of energy, data, so consistently. So this algorithm, AI algorithms, that has been now applied in quantum to make quantum more reliable. Let me explain you. In just before the pandemic, COVID-19, I was in Bay Area. Google announced their Zycomore computer, quantum computer display. So I was one of them invited. So I went to see the action of a quantum computer. When they have given a loop problem, mathematical loop problem. So this problem is more on a factorization, which has huge mathematical gates to be defined. When they run this problem on a digital computer, it normally takes about 10,000 years to solve. In a digital computer, the supercomputer takes 10,000 years to solve. Same problem we tried to run on a Zycomore in 2019, just before COVID. It runs in 200 seconds. That was the first breakthrough that quantum can create enormous change in the data processing power. So now the applications, I would like to talk about the drug discovery. See, this is a massive area which really needs a lot of quantum and AI application. See, we have defined about the structure of your genomic sequence. That has been explained. Then we created relationship with muscle, disease, blood, and each and every type of your inherent physiological system has been connected with your genomics. But third aspect, which we still not able to touch, is the correction of this gene, which is a massive data management, which was not possible by any normal digital computer. When we give this problem, it hangs up after 10 days or 15 days of running. It's not able to solve. So now we are creating quantum solutions through this, and we are trying to locate how exactly we can intervene with the genomic sequencing. So once it is done, much of your problem, diabetic, cancer, predictions and all that will be easy, and we will be able to correct ahead of time. So normally we know the family tree and we can correct accordingly. So coming to drug discovery, we have been working hardly with molecules. Now we will be able to read the molecular reaction. Someone was asking about what applications. We are not talking about it. This is the application. So we can talk about how molecular reaction that carries through. Each such reaction we will be able to monitor like a live media, which was not possible before. That is the beauty of your drug discovery. I have a strange incident to do. For the Japanese prince, we were able to correct the drug discovery and quantification and created a new molecule in a gap of 15 days, which was possible with the application of quantum computing. Then comes to finance. As we know, Google does about $1 trillion worth of transactions. So every company does a huge financial transactions. But these transactions need to be really go through a proper protective layer. This protective layer is what we create called QKD, quantum key decryptor and encryptor. So this will protect. See, usually in a digital computing, you have this data which is a huge line of encryption. That encryption you will be able to devise through a sequencing program. You will be able to find out what key it is. Maybe one trial or 10 trials. Whereas quantum, it is like a fluid. It'll be running all the time. The number will be keep on changing, so you will not be able to intervene and correct it. So that is one advantage with quantum computing. Then logistics and supply chain. As you all know, you can create travel salesperson. Problem of global chain involving millions of variables, it becomes very complicated. If you see, the Mercy Lines and everybody has been adapting to artificial intelligence, but they have their bottlenecks. Every port of entry and exit, they have the bottleneck of managing their inward and outward. So now we are setting up a foolproof logistics out of this. As I told you, I have connected cybersecurity and space science because space data becomes so important. It cannot be shared to anyone. So space theft is happening. Many of those spy satellites are sent by the various countries are trying to spy various important data and trying to steal away. Now with the quantum enablement, we are protecting it completely. So the gravity mapping, which was not possible before, now we are able to do it very comfortably. And the quantum sensing, so sensing of data, various sensing of senses that we have been connecting through digital computer now become efficiently managing through a quantum media and artificial intelligence. So the confluence makes key area impact so nicely. And when we look at the landscape, we have hybrid architecture, quantum classical hybrids. Now when you look at the quantum computing, there are two kinds of quantum computing. One is a superconductivity. We called IBM comes up with a superconductivity quantum computing, and another is trapped ion quantum computers. These computers with artificial intelligence. Now what happens? Quantum computer per se, you can't go and operate anything out of it. Quantum computers will be connected through a cloud, and the cloud you can access through a digital computer only. So digital and quantum has to work together, and this is the media where you will be able to solve your complex problems. So now agentic AI, we are talking about it, which is now, let's say it's connected through a quantum computing. It can handle huge volume of data, and any bundle of hardware which are located across world can be connected and co-create the agentic AI. So it will reflect the technological superiority any part of the world at the same time event, which was not possible in digital computing. So now that barrier is also gone through. Then energy factor. The previous speaker has been talking about energy in India is going to be difficult to manage. But now these centers which are consuming 50 megawatt of power, once we have this quantum interface, we will be able to work on 50 kilowatt. So we can reduce by 1,000 times. So energy consumption, we are rather saving energy through quantum enabled traction on energy. So now the grids are connected. Earlier, which was not connected, there is an island of grids. Now the grids in India has been connected. We don't have a power shutdown outage at all. So this now will be, once we interface, these are all missions that we are going to work now with the new quantum computing setup. So energy factor, it's going to be a green alternative if quantum is mixed with that. And in terms of collision of two worlds, the classical AI, which search through, very sorted linear working. It's a linear fashion. This goes through a square root. That is the beauty of quantum. In other words, it goes on exponential. So every digit goes on exponential. You can think of the value. It is phenomenal speed and phenomenal output. And integration, you have unsupervised learning and pattern matching, which was not supervised at all. Once your algorithm is fixed, there is an algorithm called Shor algorithm. You can fix your final expectation that will get to drive through this. So Grover allows massive unlabeled information at a time from multiple resources. So there is another variational quantum eigensolver. So this is another hybrid quantum computing. They use this algorithm and it's quite interesting. This is what largely used for quantum chemistry and material science. When you get into material science, see, till date we don't have a easy way of fixing what kind of a material composition in any component, which is not possible. Now with a quantum interface, we will be able to synthesize any metal or physical medium into its material science property, and it can throw out the results, which is so easily do it. I think subatomic level we will be able to go through and trying to classify the material properties. And quantum neural networks, as you all aware, LLMs needs a lot of quick throughput. It cannot be taken very, when the reaction time starts extending, your LLMs are not acting properly. It will have its own problem. Many of the kids who are developing from a deep learning to an LLM, they will face the problem of now with this quantum interface, we will be able to drive it at a very faster things. So quantum neurons, we call it qubits. So we are shifting from normal bits, zeros and one, to 0 and 1. So the mapping is superimposed. So that is the beauty of this. And bottom line, I think we have to embrace quantum computing now to lead in digital information and innovation. So entire place, whoever I try to meet, whichever forum I go. Recently I was present in UK and for a quantum fora, I found everybody carries paper. So there is a huge amount of expertise and involvement is happening, which is going to make a great difference. So quantum will have its innovations taking across the world. And goal of adoption and integration is not just to do things faster, it is to perform calculations. So we have to really drive numbers. So the numbers which are classically very important as far as your whole computing platforms are concerned. So the platforms which we see in classical computing, which will take the crunching of numbers takes a longer time, and with a quantum interface it becomes easy. So we are trying to split the work that quantum will be able to do. Today quantum computers are there, but we are trying to find what application we can run on the quantum computing. See, the whole world is looking for application. So we need more problem statements to create quantum is more effective. So moving from approximate AI to exact AI, that is the message quantum gives to the world. So this quantum is now applicable to your data centers, to a wide amount of area, which is every day it is evolving. So the confluence of quantum and AI going to shift the world in a large way. We are trying to do a small piece in this. We have got an organization called Broadino. We are involved in building industrial AI, and we are using Industry 4.0 applications using quantum power. We are going to set up this in Schambach. We are going to have this quantum interface also here, and we will be involving in the research and application of quantum computing locally. We are also going to work with CQE. So the efforts are being underway. So you will shortly learn, and we will be always available for you to give you a brief about it. Thank you very much.